In this video, we show how the RESMAN reservoir surveillance technology is used to determine the inflow distribution across the reservoir interval. The well shown in this graphic will be used to illustrate how this works. There are 7 zones in this example, with each zone containing inflow control device style sand screens. These types of sand screens have a nozzle at one end of the joint that regulates the flow from the reservoir into the main flow stream. The RESMAN rods are produced at the RESMAN facility and then integrated into the screens during the screen manufacturing process. The different colored rods shown in each screen represents the unique chemical compound contained in the rods. In this example, 7 unique chemical tracers are used to measure oil inflow distribution. In a single flow stream, RESMAN has the capability to deploy over 50 unique chemical signatures for oil inflow detection and 50 unique chemical signatures for water inflow detection. When the well is static, the chemical released from the rods accumulates around its vicinity, thereby creating a high concentration of the chemical tracer in the surrounding oil. When the well is turned on, flow from the reservoir flushes out the small volume of oil containing high concentrations of the unique chemical tracer. Zones with high inflow rate will flush out this small volume of oil more efficiently than the zones with low inflow. This creates tracer concentration profiles in the flow stream that are proportional to the inflow rate of each zone. By taking samples of the produced fluid at the surface, the concentration profile of each of the unique chemicals is determined. Now for a closer look at this process. Each zone contains material that releases a unique chemical signature to either water or oil, which is referred to as an intelligent tracer system. This shows the release of the tracer begins when the rods come in contact with oil. The release rate is constant, so when the well is static, the tracer builds up in the fluid surrounding the RESMAN tracer system. When the well is turned on, the fluid from the reservoir flushes the oil with the high tracer concentration from around the rods. Zones with high inflow rate will flush out the fluid around the rods rapidly and preserve the concentration. Flow from the well transports the concentration profile to the surface, where samples of the produced fluid are taken at the surface at regular intervals and analyzed for the concentration of each unique chemical tracer. The concentration in each sample is plotted versus the cumulative production associated with the sample to create the concentration profile shown. Zones with lower inflow rate will displace the fluid around the rods less efficiently, thereby creating a more diluted concentration profile that is spread out over a larger produced volume. Now let's examine how these concentration profiles are used to determine inflow distribution by looking at all 7 zones together. After a static period, the well is turned on and each zone is flushed out according to the inflow rate each zone is experiencing. This creates a concentration profile in the flow stream for each tracer that is related to the inflow rate from each zone. Flow from the well transports the concentration profiles to the surface, where samples of the produced fluid are taken at regular intervals and analyzed for the concentration of each of the RESMAN systems. RESMAN has developed a physics-based model that is applied to the concentration profile of each tracer signature to derive a % of total inflow for each zone. The inflow rate of each zone, in barrels per day, can be determined by multiplying the % inflow by the total well rate. RESMAN has recently performed an extensive test program in a full-scale flow loop that has verified this model over a wide range of flow rates. This has shown to yield an accuracy of 5 to 10%. RESMAN is excited to provide the industry with its revolutionary Chemical PLT.